In this video, we will look at exponential growth and decay. If we look at that, it's something that tends to occur quite a lot in the biological sciences. For example, studies of population growth, and it could be population of algae, population of anything really. Looking at that population growth is usually an exponential type curve because the conditions is right, therefore they reproduce very quickly. So you're always expecting stuff to happen. So the only difference that you will have here when you compare that to your function, you will not have that negative x values. And the reason why is because your population has to start with a certain amount. So in the previous video, we looked at the graphs, and the graphs look like that for an exponential function, always going through 1. So what will happen basically when we look at exponential growth, it would be only this side of your graph, because it starts with a fixed population, and that might not be 1. It could be, but it's not necessarily 1, and it's going to grow from there. So you need to really read your question carefully to pull apart the bits so that you can understand what you have to do. So the best way for me to explain this is by a question, and let's look at the question and work through it together. For these questions, you will need to construct your own formula. It really works on the basis formula that you will say your population, that you will say for example, AN, that's what it will be afterwards, equals to A0, your initial population, and then your interest or increase, so let's just call it A, to a specific amount. So that's basically the principle it's going to work under. This is not a formula you get given. This is sort of my own made-up version of it, but it goes to it follows this principle. But the important thing is that you guys need to read the question carefully and unpick what it's asking of you. Okay, so this is basically they basically say here the population of mice increases by 20% each week, and then they can carry on further asking you how much is it after a year, 20 weeks, something along those lines. So let's just look and see how you need to construct it. So what does it look like? So the important thing that you need to see is you need to see this 100 mice, and this 100 mice indicates your principal amount. Okay, and then you can see the interest is 20%, or your increase 20%, so that's going to be, just change the color here, so your increase here is going to be 20%, and that's going to correlate to this I. And then this N, let's choose a different color, and this N will be for how long you've used this. So in this specific part of the question, it doesn't say how long it is, but we'll just make up our own hypothetical examples. So N will be the time. So let's look at what we have so we can plug it in together. So let's say the question asks you, what is the population of mouse after a week? So you will have to go back and plug it all into your formula. So you say, well, I want to know what my population is after the amount of time, and the amount of time for us is a week. I have 100 mice, and it is increasing at a rate of 20%. So you're not going to say 0.2, you're going to say 1.2. And that 1.2 is because it is the initial population. So I'll write it there. It's the initial population plus that growth of 0.2. Okay, and how long does it take? It's for a week. So after 1 week, my population is just going to be 120. And so if you change it to whatever amount of time that is, you just keep on changing your N. So if it was, for example, to 3 weeks, so I want the time after 3 weeks, it would be 100 times 1.2 to the 3. And it works like that, so I hope you get the picture. Okay, this one is slightly more easy given that they already give you a lot of information. So here they already tell you what the initial population of grasshoppers are, and and we want to know what is the area affected. So every time n changes, we'll just substitute it in and we will change it. So for example, you can have it given with this formula and then you just plug it in, but it's very rare that that will happen in your exams or so forth. So this is an example of a decay or a decrease. So can you see it decays or reduces? So that's important words to look out for, because then you know your population or your increase interest, you know that we talked about in the previous slide, that will change a little bit. So in the previous times you had to add, now you will need to subtract. So in this case it will be 1 minus 0.05. So your increase will be 0.95. And this is something you need to look out for. It will always be less than 1. So if I have to write this equation, it will be AN, and it's in 20 grams, so it will be 20 times 0.95 to the N. N will be years in this case, as you can see there, each year. So if the question then asks what is the weight of this after 3 years, your N will just be 3. Okay, so let's look at this one. This is more a specific question style format. So it's a diesel generator is switched off and the current dies according to this formula. So how lucky are we? It already gives it to us. Find I, and I'm assuming that will be current. Can you see current dies? So even if you didn't know the signs, you can still read what it is. So the current dies where T is done. So they're saying, what is the current at 0, all of those. So let's have a look. So the first one says, what is the current at time 0? So current is going to be 24 times 0.25 to the power 0, which we know is 1. Sorry, that's my 5. Oh, let me do that again. It looks ugly, sorry. So it's 0.25 to the power 0. So we know that's 1, so my current is 24. Usually you need to look and see if they give you the clue, and there they do in terms of units. So it's just amps, so you need to write down the unit. So always look for this. If you don't write the units, you will lose marks. Then you're going to plug it in with 1, 2, and you follow on like that. I'm not going to do all of them. Then it says, what current flowed the instant it was switched off? So that means time 0. So the instant, can you see the instant it is switched off? So in this case again it will be 24 amps because it is that initial time. Now they're saying plotted for this. Well, you would have had at least 3 data points there, and then all you can do is you can just plot those points, extend it a little bit further and put your arrow on to show that it carries on forever. Now the next one says use a graph or technology to find it. So we haven't done logs yet. As soon as we do logs, you'll be able to find this really easy. But because we haven't done logs yet, it's not so easy to find. So what you can do here is you can just graph this. You can go on your calculator, put this in, and then you can use your function just to read off what T is. Okay, this one you can try by yourself. Have a look through it, and if you can't do it or you struggle doing it, come and see me and we'll go through it together.